So today we're doing subtracting. This is section 2.3. So you copied at the beginning, the extra credit homework that we did at the beginning. This was part of what we copied, the subtraction rule. So what they're doing there, they're saying if you subtract A minus B, then we can define that in terms of addition, the thing that we just did, right? So A minus B is A plus negative B. Those are the same things. Now, is it true that, let me do this here. A minus B equals B minus A. Is that true? Okay. If it was true, what would the property be? Commutative. Means the order is not important. But that's not true, and you can prove it to yourself just by substituting some numbers. For example, if I say 3 minus 1 on the left and 1 minus 3 on the right, well, 3 minus 1 is positive 2, but 1 minus 3 is negative 2, so that is not true, right? So we do not have a commutative property for subtraction. Now, does that mean, what if I did, is A plus negative B equal to negative B plus A? Yeah, and that one is true because it's addition. So that one works, but the other one would not. So don't try to do commutative property with subtraction. So find the difference. So if we're going to use their subtraction rule, then we should turn it into an addition, a thing that we know. I mean, you may not do it, but I'll do it just because that seems to be the point of what they're doing here. Like, how would I change this negative 12 minus 19 into an addition problem? I would go negative 12 plus negative 19. Okay, and then by the addition rule, how do you add two numbers of the same sign? You keep the same sign and you add the AV. What does it stand for? AV. Absolute values, right? You add the size of the numbers, the positive size of the numbers, and then use the sign that they were. So in this case, we would be adding 12 plus 19, which is 31, and then because both of those were negative, it's negative, right? Okay, what if I change this one? 18 plus, and now I've got negative 7. What is the opposite of a number? I mean, if I just look at if I look at negative 7, that's saying the opposite of 7, right? Well, what's the opposite of negative 7? Plus 7, right? So, in fact, when you subtract a negative, that's really like adding. And you'll see that sometimes. When you've got a minus and negative, you always need to simplify that and make it plus, right? Don't let a minus and negative go on any longer than it has to. So now 18 plus 7, they're both positive, so the answer is going to be positive. You just add their absolute values, and that's 25. Okay, so try these two. This is your you try. So what did you get for the first one? It's not numbered. It's negative 9. And just to me, there are times when we get confused about how these numbers work against each other or not. And I always just think of the number line. If you're starting at negative 2 and going more negative, right, then, if we were going to make it into the problem like they gave us, it'd be like negative 2 plus negative 7. They both have the same sign, so we would add their absolute values, which is 9, but then we would use the sign that they both were. And the next one, again, how should you simplify minus a negative? Yeah, make a minus a negative a plus. 11.7 plus 5. And what is that? 16.7. Okay, try that one. Okay, so we got to agree, the least common denominator is going to be 6. That's the smallest number that 2 and 3 divide into. So we're going to make this 6 and 6. So what do I multiply 1/3 by so that it has the same value but a denominator of 6? 2 over 2. Okay, and you need to show it like that on a test. And what do I multiply 1/2 by so it has the same value but a denominator of 6? Not 2 over 3. 3 over 3. Right? You got to be multiplying by 1. Right? The only thing you're allowed to multiply by is 1 because that doesn't change the value. And that gives us how many sixths? How do you multiply fractions then? Yeah, when I've got 2 over 2 times 1 over 3, right, that you just go straight across. That's 2 times 1, 2, and 2 times 3 in denominator, 6. How about the second fraction? 1 times 3 is 3, and 2 times 3 is 6. Okay, now, again, we could turn this into addition. 2, 6 plus negative 3, 6. Right? So how do you add fractions when they have the same denominator? You add the numerators, right? What's 2 plus negative 3? Negative 1. So it's negative 1/6. Okay, evaluate an expression. What does it mean when we say to evaluate an expression? Substitute the values for the variables and then simplify, right? So in this one, the x equals negative 2 is going to go here. The 7.2 is going to go here. So this will be 7.2 minus negative 2 plus 6.8. Okay, now how could I simplify that? How could I simplify the minus and negative? Make it an addition, right? The minus and negative ought to be turned into an addition. So that's 7.2 plus 2 plus 6.8. Okay, and then we got to add those up. So let me add them up. 7.2. Oh, that was wrong. I need to write, when you're adding decimals, they all have to line up with the decimal point, right? So that's 2.0 and 6.8. 2 plus 8, 10, carry the 1. 8, 10, 16, 16.0. So the answer is 16.0. What is it, when I say 7.2, what does that mean? 7 and 2/10, right? That's a decimal. I'm saying that's the tenths column, 1 to the right. Okay, try to evaluate that one for those numbers. Okay, pay attention. Quiet, please. Pay attention this way. Majority's getting it wrong. So if I substitute for x and y, now I've got to add 2 negative numbers and 1 positive number. How do I do that? Can I stack them all up and add up? No, because actually they're going to work against each other, right? So maybe you don't have to do it this way, but I would probably add the first 2. I mean, if you do order of operations, it would tell you to do the first 2, right? Addition and subtraction from left to right. So those are both negative numbers. What do these two together equal? Negative 3 minus 5.2. If you needed to, you could write it negative 3 plus negative 5.2. So these are 2 negative numbers being added together. Say it again. Negative 8.2. Okay. Now you still have to add the 8. Okay, again, so how do you add numbers with opposite signs? You subtract the bigger minus the smaller and use the bigger sign. So what is negative 8.2 minus 8? Or 8.2 minus 8 is is 0.2, but then we've got to use the sign of the bigger number, negative 0.2. Okay. Okay, I'm going to skip over that one. Okay, one of the most extreme temperature changes in U.S. history occurred in Fairfield, Montana on December 24th, 1924. At noon, the temperature was 63 degrees. By midnight, the temperature had fallen to negative 21 Fahrenheit. What was the change in temperature? I mean, if it helps, you could like look at it on a number line. 0 degrees would be here. Negative 21 would be to the left. And 63 would be somewhere over here. So the total change is all of this here. So what do you have to do with those two numbers? I mean, literally you're subtracting 63 minus negative 21. But again, what do you do when you subtract a negative? You add. So it's actually 63 plus 21, which is 84 degrees. And that does look like a big change in temperature. I'm glad I wasn't working outside on that day. Okay, a new car is valued at $15,000, and 1 year later it's valued at $12,300. What's the change in value? What's the operation you do to figure that out? It's a subtract, right? A straight subtract. Minus 12,300, right? 0, 0, 7, 2. Okay, here's the homework. Write that down, and then we're taking a quiz.